This video tutor explains the insert function on circular cube. So in order to define the insert function, the method is start with a return type followed by class name followed by scope resolution operator followed by name of the member function insert. The element that you want to insert, it is passed as an argument, so that this will be read in the main function, and when you call this one it will be passed as an argument followed by opening curly bracket, closing curly bracket. Now in order to derive this code, 7 cases are there. Case 1, the circular queue is empty, so that f is -1, r is -1. How did f and r get -1? Inside the zero argument constructor, programmer will write f is equal to -1, r is equal to -1. Now in order to get the second case, you insert an element, you get a new case. How do you insert the element? By default, 2 is taken as the upper bound, 0 is taken as the lower bound. So if you want to insert element 10, that should come through the rear end. So this is vacant, vacant, vacant. So the new element 10 must be inserted here. Now in order to insert 10 here, what the programmer should do is f must be made 0, r must be made 0, and to CQ of r, 10 can be inserted. Why should the programmer make f and r 0? Because the rule is f should contain the index of the first element, r should contain the index of the last element. When there is only one element, that is the first element and last element. So f and r should contain 0. Now in order to get the third case, you insert one more element. This is the last element because r is 0. So new element must be inserted here. Now in order to insert the new element here, it is r plus plus. R must be made 1, and to CQ of R, the new element example 20 can be inserted. Now in order to get the fourth case, you insert one more element. So this is the last element. The next element must come here, and in order to insert the next element here, it is R plus plus, so that your R becomes 2, and to CQ of R, next element can be inserted. Now insertion is not possible because circular queue is full. So in order to get the fifth case, you delete one element. The first element in the circular queue is the first one to be deleted, and in order to delete this, the method is f plus plus, so that your f becomes 1. And when your f becomes 1, the meaning is for my program, the first element is present at index 1, or CQ of f20 is the first element. This is still there in the array. It has become a garbage value. So this garbage value I am not writing. Now in order to get the sixth case, you insert one more element. This is the last element, so the new element must come here, and for the new element to come here, r plus plus will not give you 0. So you should write r is equal to 0, and after that, to CQ of r, the new element can be inserted. Now in order to get the seventh case, insertion is not possible, so you delete one element. First element in the circular queue is the first one to be deleted. So in order to delete this, the method is f plus plus, so that your f becomes 2. Now when f becomes 2, the meaning is for my program, this is the first element, this is still there in the queue, it has become a garbage value, and the garbage value I am not writing. This can be continued finitely many times, but in order to derive this code, I need only 7 cases, and these are the 7 cases to be considered. Now the first point, if the circular queue is full, you cannot insert an element, or insertion will lead to overflow. Out of these 7 cases, which are the cases where the circular queue is full? Case 4, circular queue is full. Case 6, the circular queue is full. What is the speciality about case 4? See, f equal to 0 and r equal to upper bound. That is, from index 0 to index upper bound elements are there, which means the array does not contain any vacant memory location, which means the circular queue is full. So one condition is f equal to 0 and r equal to upper bound, the circular queue is full. Or it can be the speciality about case 6. See, this is the last element because r is 0. This is the first element because f is 1. So you can see that immediately after the last element, if the first element comes, the circular queue is full, and for that you don't need this figure, because immediately after the last element, if the first element comes, the meaning is there are no vacant memory locations between last element and first element, which means the circular queue is full. So how can you write the condition immediately after the last element the first element comes? That is r plus 1 equal to f, then also circular queue is full. So the two conditions for overflow are 1, f equal to 0 and r equal to upper bound, the circular queue is full, or it can be r plus 1 equal to f, the circular queue is full. So you can write the condition like this: f equal to 0 and r equal to upper bound, or r plus 1 equal to f, insertion leads to overflow. Else you can insert an element. Now in case 1, how do you insert the element? The speciality about case 1 is the circular queue is empty. So if the circular queue is empty, in order to insert the element, f must be made 0, r must be made 0, and to CQ of r, the new element, here the new element is there in E, so the new element E can be inserted. So let me write the code for case 1. If the circular queue is empty, that is if f equal to minus 1 and r equal to minus 1, meaning case 1, the circular queue is empty. So in order to insert the element, f should be made 0, r should be made 0. Now for this, if multiple statements are there, hence you need the opening and closing curly bracket, and after that the new element E can be inserted to CQ of r. Here r is 0, so to CQ of 0, the new element, example 10, if E contains 10, here 10 comes. Now one doubt that may come to your mind is, why should I make f and r 0? Because the rule is, when you insert an element, f should contain the index of the first element, r should contain the index of the last element, and when there is only one element, f contains 0 and r contains 0. Now else, in case 2, how do you insert an element? This is the last element because r is 0. So new element should come here. So for the new element to come here, it is r plus plus. R must be made 1, and to CQ of r, the new element can be inserted. So here it is r plus plus. Let this be a pending case. Later we will write the code for this. In case 3, how do you insert an element? This is the last element. So new element should come here. So here r plus plus will give you 2, and to CQ of r, the new element can be inserted. So here also r plus plus, pending case. Later we will write the code for this one. This case already considered. In case 5, how do you insert an element? This is the last element. So new element should come after the last element, which means the new element should come here. And for the new element to come here, r plus plus will not give you 0. So here you should write r is equal to 0, and to CQ of r, the new element can be inserted. So now let me write the code for case 5. If r equal to upper bound, if r equal to upper bound means size minus 1, in order to insert the element, r must be made 0, and the new element E can be inserted to CQ of r. And in all the remaining cases, it is r plus plus. Associated with this else, multiple statements are there, so you need the opening and closing curly bracket. So this is how you define the member function insert for circular queue.